And actually, I'd like to start with a first question to Dr. Isaacs, because I saw in one of the charts where you generated about a 60% predictive model.
Right.
There appeared to me to be 6 orders of magnitude of difference in migration
across
in the measured data.
Yes.
Is that really true? And can you talk a little bit more about that? And so that's a million-fold migration difference?
Right. So it had a lot to do, there was that large range, and it had a lot to do with the initial concentration. So things up on that far right-hand, very, very high side were plasticizers with very, very high concentrations.
So very high,
high initial,
significant ability to migrate.
30% concentration of the tested material was the chemical. And then the things down at the bottom were much lower. And I will say the database that we obtained had no non-detect information, so it was only detected. So normally we would have a database where you have a bunch of non-detects and do some type of consideration of a left censoring type approach. But in this case, those were actually measured values.
Okay. Yeah, I think that's just important. It struck me in this context of, I think in the previous discussion there was this issue of, do we look just at hazard? Do we look at risk? I think, I'm not putting my thumb on the scale of the risk side, but I am struck by the fact that the exposure potential can differ quite a bit.
It can differ quite a bit.
And therefore, it is important that we think about it. And so, hence
right.
this conversation.
Right. And I think that's the strength of the approach where, you consider uncertainty.
Uh-huh.
You make sure that you have the, population variability. I mean, right now we're just mainly in our forecasting methods, we can really only look at the population median, and so we can put some kind of uncertainty bounds on the population median. But then you have the whole issue of population variability in there as well. And so we're working on, in the future, hopefully we'll be able to get exposure predictions or exposure inferences from NHANES, for example, for a 95th percentile or higher percentile. But even just looking at the medians, making sure that you can capture several orders of magnitude of uncertainty is very important, because even that's meaningful. Like I said, if you're off, you have a 4 orders of magnitude uncertainty, but you still may be, 4 orders of magnitude from the highest inferred dose that would cause, or assumed dose that would cause any type of biological interaction. So, it's uncertain, but it's meaningful.
Mm-hmm. So actually, I'd just love to give you, Judy, a moment to respond to the panel that you just heard, and sort of bring in some of the things that you raised in your initial panel. Any thoughts that you might have about how it all fits together?
Yeah, so just for full disclosure, I was leaked that question.
She didn't get a chance to speak on this panel, and I wanted to make a bridge, so I did, I confess.
So I was taking notes, so just really quickly. There were 2 things that happened in these talks, and I'm going to focus on yours since you're here. But so Emma, you made a comment that ubiquitous components aren't necessarily from the packaging, and then you were just asked a question about uncertainty. And I think it's important to remember that there are some people who feel really good about data, measured data, because you measured it, it's in there. And then there are people who feel really good about models because you can capture things that you don't get from what is typically a small sample size or a unique situation that isn't generalizable. And I would just say that I think we need both. And I just, if I have time, if I can just do 2 very quick anecdotes about just to support that statement. So some of you may be familiar with writings by Antonia Califat at the Centers for Disease Control and Prevention. So she has a great example of triclosan. So they're measuring triclosan in NHANES urine samples, and they cleaned their lab out completely because it kept showing up in their blanks, and they finally got to the point where their blanks were clean. And everything was going great. And all of a sudden, they started seeing triclosan spikes in their blanks. And it took them a really long time, but eventually they figured out that one of their lab techs was going out to another building for lunch, washing their hands with the soap that was in that bathroom, which was antimicrobial, coming back to the lab. That's all it took to contaminate samples. So when you're looking at measured data, you really have to be mindful of the fact that the process used to collect that information is critical, and that quality control measures are essential, and if they aren't documented, you should be, the hair on the back of your neck should be going up a little bit or a lot. And in terms of models, I would say, as kind of an equivalent analogy, some years ago we modeled infant exposures to chemicals in breast milk, and we thought we had a pretty good understanding of changes in those concentrations over the course of lactation because we had some data, biologically it all made sense. We felt pretty good about it, but not quite good enough, and so we went out and we actually did a study on this, and we found out that our assumptions were completely wrong. And so I think, we can have conventional wisdom that we really believe, and it's like wishful thinking. We go into developing our models thinking that we really understand something, and we can still be surprised. And so I think having both the modeling and the exposure, the actual measured exposure information to keep comparing against each other is going to be essential as we move forward.
And in talking and thinking about how these models are built, so much of this, the model has to be built on a lot of data, obviously. And it sounds like, I'm sort of interested in how the data sharing work between the agencies, and and how we can sort of broaden that in terms of having access to the information that would form the basis for the kind of exposure information we need. And I'd love both of your thoughts actually on that.
Yeah, I can speak for the EPA. So that last slide I showed with the new curated chemical information, that's going to be part of what we call the CompTox dashboard. And that dashboard will ultimately also include all of our exposure predictions, all of the data that we use to build that. So we have an entirely analogous project to look at concentrations of chemicals in consumer products, and Meredith knows about this. So we have a database called CPDAB, where we have collected data from MSDS sheets and data from ingredient lists and measured data. And our goal, and I think that Tina Bahadouri, our National Program Director, should really be commended, is transparency. We want to be transparent with our data. And so one of the goals of the whole dashboard program is to make sure that we have a sustainable framework for disseminating that data. And even our models. We're working to include our models, but the human exposure model for consumer products that I work on, we're packaging them into R packages that then could be shared, and that basically anyone could take that R package and regenerate all the exposure predictions that then go into our consensus forecasts. So I can't speak for any other agency, but I think at EPA we're making a concerted effort to kind of change the way we think about transparency and data sharing and not being so secretive, and basically acknowledging that by making our data more available, it's going to do nothing but improve. I want, as a modeler, I want someone else to look at my stuff. I like it when I have postdocs to go over things, and when I hand things off to beta testers or colleagues to say, you might even, A, they find errors, right? B, they have entirely different ways of thinking about things that I hadn't even considered. And that does nothing but improve the ultimate, scientific quality of your work. So that's my opinion.
From the European side, I was going to ask a question in terms of, have you corresponded with the leaders on the FACET project?
I talked to Kian. I know Kian O'Mahony.
Okay, so basically the FACET project, it's an acronym for Flavors, Additives, Food Contact Materials, Exposure Task, whereby there was basically took the substances that are used in food contact materials. So all the trade associations in Europe provided their inventory lists effectively. So that told us the substances that were currently used. In plastics legislation in Europe, we've got a list of substances that are permitted for use. So again, that was accessed. And then took food consumption databases, used migration modelling where we didn't have migration concentration data, used the migration models. Those migration models are accepted in European legislation, and developed a exposure model from all of that. That was European Commission funded, and so is publicly available. It's one of those things where the data's probably not in a format that would be ever useful if I don't know, you called them or something, but in terms of sharing it between these things, as long as you've been in touch with Kian and you've got that source, then I think it's really sensible to bring all of the data that's available together.
right? And we did do some of the pulling of the compounds from their lists. I think there are some proprietary pieces of information in the model as far as like which packaging formulations, so which chemicals are in which packagings.
Yeah.
Some of that is still kind of hidden
for
intellectual property reasons
Absolutely,
that we talked about earlier. But yeah, so we try to, when we were able to share data, we try to.
And the same with the European Food Safety Authority. They can't put everything on their website because of those proprietary reasons.
Yeah.
But again, when somebody submits a substance for approval through the dossier, the intention is that they give the analytical method that's been used, and that analytical method then goes to the European Joint Research Centre, so is available for compliance testing and enforcement. So again, there is that openness, and the substance itself, quite often we can't, if we were doing it as a testing lab, we can't get the substance. There is a requirement for them to supply the substance to the Joint Research Centre as well, such that monitoring can happen and such that concentration data can be derived. So that is part of that, the process that EFSA follows.
I don't believe we have that requirement here in the U.S., and so that is very interesting to hear. I'd love to take questions from the audience. Are there any questions? I see.
So I have a couple questions that have come in from the internet, and one is for Dr. Bradley. Does the EU set any limit for contamination from indirect sources, such as printing ink, during processing of the can forming?
So the legislation that would be applicable there across Europe would be the framework regulation, and that food contact materials should be safe. And because what we don't necessarily have is we don't have rules for everything, we do in Enology tend to apply the rules for plastics. So if there is the potential of migration, we've had examples, I don't know if you call it set off. So basically if you've got transfer from your food contact, if you've got things stacked, and it's printed on the external surface, and you would say there was a barrier between that external surface and your food stuff because you've got an aluminium layer or something like that, but it was stacked, there is the potential of that printing ink to contaminate your food contact surface. And therefore you'd still have to abide by the levels that are applicable for plastics. So once you put that in the food, it may have some of those external chemicals on. And therefore that's we had the Tetra Pak type products here earlier, and that was one of the things that was there was the ITX a few years ago in Europe, was a big issue of that photo initiator from the external surface going onto the internal surface and transferring into the food stuff. So all of that is a requirement of the general safety of the food contact material, that the food contact material from any source, whether it be the printing ink, the coating, the aluminium itself, for example, the paper and board, the plastic, does not transfer chemicals at levels that endanger human health. So everything's covered through that route.
Thank you. I've got one more that's getting to your point about how analytical techniques are driving down limit of detection. So the question is, do you have any suggested detection level we should ask the lab to assess?
It would generally depend on toxicology, which I think we'll go on to later on anyway. But we would, if I was to develop a method, and we would generally be aiming at 10 parts per billion as our limit of quantification rather than our limit of detection. And when we're talking about those ubiquitous chemicals, we'd want our limit of detection obviously to be lower, but taking into account all of that background level that could come from other sources, we would want our reporting limit to be at that level. So if we haven't got any tox data, if we don't know at all, we would screen down to that 10 part per billion level.
Any questions in the room?
Hello, Vina Singla with the Natural Resources Defense Council. Thank you all for very fascinating presentations. My question is for Dr. Isaacs. I was really struck by the 1,600 or so different chemicals in your study used in food packaging materials, and I wondered if you could speak to your model's ability to predict the profile of how many of those substances a typical person might be exposed to in one day, and whether any of those had similar bioactivity profiles.
So I do, well, as far as similar bioactivity profiles, I know that there are several hundred of those on that list that are on the endocrine disruptor screening program chemical list. So, while they're not known to be endocrine disruptors, they're at least being screened to be potential endocrine disruptors. Now, as far as how many each person is exposed to, I think that's a huge data gap in our modeling. So I went through it very quickly, but what we basically assume is that we don't have any information about chemical occurrence. So we know we use standard FDA consumption factors. So 80% of your in daily intake is contacting a polymer food substance. But what we don't know is for each of those chemicals, what fraction of polymer food substances is it in. And I think that's when you're really wanting to bring. I had those predictions that were couple orders of magnitude higher than the NHANES intakes. When you want to try to bring that down and refine that's a huge potential refinement. If we had better data sharing with industry about, okay, well, these particular chemicals, maybe not so much, even what particular foods or food packaging, but what types of food packaging. Are these chemicals only used as plasticizers in some certain, polymer matrix, or are they only used in a resin? I think even that type of refinement could be very, very helpful. So I hope that answers your question.
And I was just wondering, perhaps the analytical chemists can help with some of that, with some of the non-targeted testing and so forth. You must have a pretty good sense of which things are showing up paired with what types of foods or applications. Or
Yeah, sure. I mean, so on the list for, you have 1,600 for plastics, I think, from the EU, which is our positive list, that we don't see all of them. And, well, it's slightly different, but we did a project a while ago where we wanted to look at printing inks, and the Swiss ordinance had just been published, which again contains thousands of chemicals used in printing inks. So that, well, what do we survey? What do we want to measure in food? So we did some screening in terms of solvent extraction of some printed packaging materials. Saw probably, I think in the end we had 20 chemicals that we selected from this list. And that's, I mean, some may have been there, but not detectable levels. Obviously, if they're not at high levels, we're not going to detect them in the foods. So we were screening out at that level as well. But obviously, there was nowhere near the 2,000. But when people have historically, I mean, this legislation has been in place since the 70s. When somebody's wanted to use a substance, it gets added to the list. It doesn't then get removed. So it's got a lot of historical. So as things have been removed, I mean, it would be removed if it was suddenly found to be toxic or whatever, or at too high a level. But it's not moved. So it's just been added to rather than refined. And if you think about what's actually used, then it's probably, well, it is a small subset, but we don't know how many.
Do you have a sense of, everybody probably wants to know, so out of those 1,600, are you seeing, half of that or 10% of those or in your testing?
To be honest, there's so many different pack formats now that you'd need to test more than we've ever tested for me to be able to answer that question.
Okay.
Sorry.
Just curious, when you said nowhere near that number, I was just trying to get a sense of what we were dealing with.
We would tend to, maybe when we're doing a survey, we'd be picking for example, we did some monomer surveys for plastics, so we just picked monomers used in, I don't know, acrylic polymers or something like that, and tested those. We weren't necessarily looking for everything at that level.
Another question over here.
Hi there. This question's for Emma Bradley. So you mentioned you had some testing methods available at your disposal to look at the presence of the chemicals when they're occurring on the surface of the foodstuff and also in the bulk of the product. I assume deeper in, and I apologize if I have that incorrect. Could you expand on that, and can you tell me if these are universally accepted methods and how commonplace that type of testing is to differentiate between the ubiquitous chemicals and the intentionally added packaging chemicals?
Okay, well, we talked about phthalates. Someone mentioned phthalates as a substance concern a while ago. We did a project where we wanted to be able to demonstrate that the phthalates we were measuring in the food was coming from the recycled carton board that the product was packaged in. And for a solid foodstuff, those phthalates will transfer at the surface, but they may not diffuse far within the foodstuff. So what you see is, if you've got a solid food and you slice it the distance away from the packaging, you can see that there's a decrease in concentration as you go to the bulk of the material, and that gives you the confidence that packaging material is a source of that. And we published, we did that work for the Food Standards Agency, so it's available publicly on the Food Standards Agency website. It's not it's no rocket science. I mean, you literally, it is just slice and measure each slice and see the concentration gradient. If there isn't a concentration gradient, then the other things we did was we measured we tested the packaging. Obviously, it's not in the packaging and it's in the food. It's not from that packaging. You'd still always see residual levels. And the other thing is if it's for the phthalates, if we saw 4 phthalates, we'd expect them to migrate at very similar rates. And therefore, you'd expect your profile in the packaging to be similar to your profile in your food. So all of these added together give you the confidence that it's the source of that chemical is that packaging material.
Great, thank you.
I think we have time for one more question. Over on this side. Maricel.
Yes, really fascinating talk. And I was wondering, many of the food contact substances are also used outside of packaging. Probably a large number of them are used during the manufacturing process. So I was wondering, in your exposure modeling, are you taking that into consideration? Because exposure will come, what you see in an NHANES is
Right.
in the food, but as Dr. Bradley just said, it could come from any other source that is not the packaging.
Right. So our forecasts try to take into account as many exposure pathways as possible and look at the aggregate. So again, I had to kind of fly through it, but I did have a slide where we were actually combining the results for the NHANES chemicals from consumer product, a consumer product model, things like phthalates and hairspray and nail polish, with the results for phthalates from the food contact. And then again, we can kind of use that consensus statistical evaluation to say, okay, well, how predictive of the NHANES exposure are these different pathways? And in the food contact, for phthalates, the food contact and the consumer product were comparable. So I think that's one of the strengths of what we call our kind of a domain of applicability approach to our consensus modeling, is that you can look at the contribution from these different pathways to the biomarker. And certainly, you definitely want to consider aggregate when you're doing risk-based prioritization, because you want to look at how the exposure from one particular pathway is bumping you up closer and closer to that level where you may be concerned that you're overlapping with the bioactivity.
Excellent. Well, thank you all so much. This was a great panel.